Elaine, and let's enhance your grasp in math, in nature, and arts.
First in the topic is the Fibonacci sequence. This is a set of numbers that starts with 0 and 1, and each subsequent number is the sum of the two preceding numbers. As we can see, 1 plus 1 is equals to 2, then 1 plus 2 is equals to 3, and so on. But what if you don't know the prior consecutive numbers? How would you determine the Fibonacci number? We would use the by-net formula, where f of n is equal to quantity of 1 plus square root of 5 over 2 raised to n minus quantity of 1 minus square root of 5 over 2 raised to n all over square root of 5. Let us see the next sequence. So we know that the next number would be 89 from the sum of 34 and 55. You could try using the by-net formula and we would still get 89. Next is the golden ratio, which is illustrated on the screen. Let's get the Fibonacci sequence once again and input the set of numbers into the ratio as illustrated. We could notice that all of these numbers are equal to 1.618, which is the golden ratio. We could deduce that f of n is equal to f of n minus 1 multiplied by 1.618. Let's try using this once again. We know that the next number would be 89. Using the golden ratio, let's multiply 55 and 1.618. We would get a number approximately to 89. We could turn this ratio into a spiral, and this spiral is said to be the reason why humans find something attractive. Like the pictures on the screen, the ocean's creation of low pressure area, petals of the rose, stairs, even Mona Lisa, a seashell, and even architecture. They all use golden ratio. Now, look around you and notice which ones do you find attractive. Can you find the golden spiral behind it?
Let's try doing fractals. First is the Sierpinski triangle. Let's start with a triangle, then get another triangle and shrink it in half. Put that half in the first triangle. Repeat that steps until you are satisfied. Doesn't it look the same as the first triangle? Next is the Koch snowflake. It also starts with a triangle. However, you invert another triangle to make a base of the snowflake. You duplicate those snowflakes and attach it to the edges. You repeat it again until you are satisfied. Lastly, let's make a Koch island. For a change, this is our motif or repeating pattern. Then this is the base. We replace the base with the motif every time we see it. It looks like this until you repeat it again and again. These shapes are what usually are used for data and signals in your phone. Fractals is not just seen in technology, but also seen in nature and human body. See the examples in the website. Lastly, let's analyze an example for symmetry. Let's see this picture. What symmetries and isometries can you notice? This is a wallpaper symmetry because it has repeating patterns in different directions. We can also see a freeze pattern, which is repeated in the translation. These repeated freeze patterns are what makes up a wallpaper. We can also see glide reflection of circled leaves, and other leaves are also circled for glide reflection. We can see rotation of leaves from the circled to top leaves. Not only that, we can see a rosette symmetry from the circled leaf. It is dihedral symmetry since it has a center point. It only has one symmetry, however, if we repeat it, it would look like a clover. Look around and see whether these symmetries or isometries make up for the beauty of your environment.